Hi guys, in this episode of Shri series, we're going to be talking about ionic bonding. I'm going to give you a brief overview of what ionic bonding is, and then we'll look at one or two examples on how we can use ionic bonding as an application. Alright, so in a nutshell, what is ionic bonding? Alright, so there are two things you got to remember. What is the bonding between, and how is the bonding taking place? Alright, so ionic bonding in a nutshell is a bonding between a metal and a non-metal. Alright, so you pick any metal on the periodic table and you pick any non-metal. The way they bond via a process called ionic bonding. Alright, so it's bonding between a metal and a non-metal, and this type of bonding occurs via transfer of electrons. Transfer of electrons from metal to non-metal. Alright, so ionic bonding is a type of bonding that occurs between a metal and a non-metal, and this occurs via the transfer of electrons from the metal to the non-metal. Alright, now if you remember from the previous videos, metals by nature, alright, so if you look at a metal here, metals by nature are losers of electrons. Alright, so they lose electrons and therefore are referred to as cations. Alright, so metals are cations because they lose electrons and are therefore positively charged. Alright, so metals lose electrons, are referred to as cations, and are therefore positively charged. Alright, simple example of metal or cations, if you look at sodium, sodium is Na plus. You look at calcium, calcium's 2 plus. Aluminium, aluminium is 3 plus. Alright, so you will notice that sodium, calcium, and aluminium are positively charged particles, and therefore they will be cations. They lose electrons. Alright, when you look at anions, for instance, so I'm just going to rub this out and look at the properties of anions in terms of their charge. Alright, so if you look at anions, for example, anions display the opposite effect as cations. Alright, so if you look at anions, they are gainers of electrons. So in other words, they gain electrons that the metals lose, and therefore they are anions, and as a result of that, they are negatively charged. Alright, simple example, if you look at oxygen, oxygen is 2 minus. You look at chlorine, chlorine is minus. Alright, you look at bromine, bromine is minus. Alright, so non-metals are negatively charged because they gain electrons from metals. Alright, now let's look at how ionic bonding takes place in a compound, say sodium chloride. Alright, so I'm just going to rub this out and I'm going to give you an example of how ionic bonding takes place here. We're not going to be talking about the properties, that's reserved for another session, but I'm going to give you an example of how ionic bonding takes place. Alright, so let's look at sodium chloride as a simple example. Alright, so like I said before, sodium chloride, the word formula is sodium chloride, and the chemical formula is NaCl. Alright, so if you look at sodium, what is the charge of sodium? Now I'm going to show you why through ionic bonding the formula is sodium chloride. Alright, now if you look at the charge of sodium, we know very well sodium's Na plus, and you look at the charge of chlorine, chlorine is Cl minus. Alright, now let's look at the outer electron. Let's look at the valence electron, because like I said before, it's the last electron that is absolutely critical in this bonding process. Alright, so if you look at Na, you look at sodium, alright, you look at sodium in the periodic table, its atomic number is 11. Alright, and if I was to write down the electronic configuration, we know it's 2, 8, 1. So in other words, it's got 1 electron in the last shell. Alright, let's look at chlorine. Alright, if you look at chlorine, alright, chlorine's atomic number is 17. All right, and if I was to draw the electronic configuration of chlorine, that's going to be 2, 8, 7. So really what happens is for chlorine to obtain octet, it needs that one electron to complete 8 shells in its valency shell. All right, so it needs 8 electrons in its valency shell. All right, how do we draw this shell? All right, so like I said, we can draw it like this. So if you look at sodium, so that's your nucleus. We can draw the 3 shells like this, all right, and then we can put cross. So 2 electrons, that's 8 electrons, that's 8 electrons there, all right, so that's 2, 8, and then the last one is 1 electron, all right. So that's the dot Lewis structure of, let's say, sodium, all right. We're drawing the last shell of sodium. We can do the same thing for chlorine. So if you look at chlorine here, we've got nucleus here, you've got the first shell, we've got the second shell, and we've got the third shell, all right. And if I was to, let's say, I'll do dot for non-metals, cross for metals. So you've got 8 here, and then 7, 1, 2, 3, 4, 5, 6, all right. So 1, 2, so that's there, okay. And I'll just cancel that out and put the dot there. All right. Now, I've seen students drawing like this. However, you can also draw the last shell. So I know sometimes in exams, they focus on drawing the last shell because, like I say, the last shell is very critical. All right. So this is what is happening here. Sodium's got 281, it's got 1 electron in its last shell. Chlorine's 287, it's got 7 electrons in its last shell, and therefore ionic bonding occurs whereby in this process that 1 electron moves there. Alright, so sodium, which was initially Na, so this was initially, and this is chlorine. So sodium that was initially Na loses an electron and therefore becomes Na+. If you look at chlorine, initially it was Cl, it gains an electron and therefore becomes Cl-, and therefore the final formula of sodium chloride becomes NaCl. So we've shown ionic bonding to explain how sodium and chlorine bond and what's the final formula, which is NaCl, using the last shell in this case here. Alright, so that's how you can use sodium chloride. Let's look at another example, say calcium chloride. Alright, we're going to do exactly the same here. Okay, so I'm just going to rub this out. So with calcium chloride, you need to understand where calcium is. Alright, calcium's in group 2 of the periodic table. So therefore, when it's in group 2 of the periodic table, it has 2 electrons in its last shell. Alright, so let's look at calcium chloride. Alright, so if you look at calcium chloride, we know very well the formula is CaCl2. Alright, so let's look at calcium and let's look at chlorine. We know calcium's atomic number is 20 and therefore its electronic configuration becomes 2, 8, 8, 2. We know chlorine's atomic number is 17 and therefore its electronic configuration is 2, 8, 7. Alright, so this is how you see this. Okay, now let's draw the last shell of calcium. Okay, now if you look carefully here, I can draw the full or I could draw the last, but for the sake of showing the shells here, I'm happy to draw the 4 shells present. So you've got the nucleus, you've got the first shell, second shell, third shell, and your fourth shell. Alright, so if you look at calcium there, we'll put an X for the metal. So you've got 2 electrons here, and then you've got 8 in your second shell, and then you've got another 8 in your third shell, and you've got 2 in your last shell. Alright, let's look at chlorine, for example, in this case. So I'm going to draw the nucleus, the first shell, and the second shell. So we're going to use dots for non-metals. So you've got dots here, 2 shells in the first electron, 8 shells in my second electron, and 7 shells, alright, in my third electron. Alright, now, if you looked at my previous question, you had sodium which had 1 electron. Therefore, what happened was that last electron gets transferred. But in this case, we cannot exactly do that because calcium's got 2 electrons. We can't transfer those 2 electrons because what will happen is chlorine will end up having 9 electrons and that will break the octet rule. So in this case, what needs to happen is for chlorine to have the other electron, it needs to have another atom there. So what I mean is you've got 1 electron being transferred there, all right, and you also need another electron transfer. So what we need to do is we need to draw another chlorine, all right. So you've got 2, you've got 8, and you've got 7. So what happens is 1 electron goes to 1 chlorine and the second electron moves to this chlorine. So really what happens finally, that X, so in other words, that X is the electron from calcium and you've got the other X from calcium. So you've got 2 chlorines to 1 calcium, and therefore that explains why if you look at calcium's valency is 2 plus, chlorine's minus, and the formula for calcium chloride is CaCl2. So this explains via ionic bonding how the transfer of electrons taking place. Alright, so this sums up ionic bonding. 2 things to remember. It is formed between metals and non-metals, and the form of bonding occurs via the transfer of electrons from the metal to the non-metal. Alright, thanks for listening guys. Bye now.